Hello, I'm Mr. Franklin. Today we're going to look at Bohr's model of the atom. You have probably, most people by the time you get to high school chemistry, you have seen this model before where you see a nucleus with at least a proton and you know that electrons go around the outside of the nucleus. But Bohr said something that's very unique and very specific that we need to talk about. And to understand that, we need to talk first about energy, okay? So let's think about this as if the electron were running around a track. If you've ever run around a track, you know that the shortest distance is on the inside track, so you don't actually have to work as hard as if you were racing next to somebody on the outside track to keep up with them. You actually have to run faster on the outside in order to stay together. Another way to think of it is if you've ever ridden a merry-go-round, as you're spinning, what happens? Faster and faster you go, the more to the outside of the merry-go-round you're pushed, right? So if I were to take this and spin it, the faster and faster it goes, the further out the end goes. Okay? So here's what happens. If we take an atom and we add energy to the atom, it goes to the electrons and it causes the electron to go further out and orbit at a higher orbital, at an orbit further away from the nucleus than when it started. What happens though is eventually, as the electrons are going along, eventually they're going to return to where they started. Okay? But when they do that, there's a law called the law of conservation of energy that says energy cannot be created nor destroyed. So when this goes back in, to get this cord to go back in, I have to pull energy out of it. Okay? So the energy has to come out. So to get this to come out, what actually happens is, as this electron comes back down into where it started, it releases a ray of light. A single piece of light we call a photon. Okay? And this is what's unique about this atom, is the rays of light that come off of this atom are very specific colors, very specific lines of light. When you watch the light video that I'm going to make, you're going to see that we could have a full rainbow of light, and we're going to talk about what the full rainbow, some parameters of what makes up light. But as you look here, you're going to see that we have specific lines of light. They're only set colors out of that rainbow. Each color has its own energy. Okay? And we can calculate energy as Planck's constant times the frequency. Okay? We're going to talk more about what these symbols mean later, okay? But the change in energy, this change in energy is represented by this equation. So based on the color of light that comes out, I can determine where this electron came from. So this is what we're going to do. We're going to take these specific lines of light in our experiment coming up, and we're going to measure a wavelength, and then we're going to calculate the frequency, and then we're going to calculate the energy and figure out what energy level did those electrons come from. Okay? That's where we're headed. So this is the basics of the Bohr model. In another video, we're going to talk about light in general. Then we're going to talk about there's another equation, and it's this one. C equals frequency times wavelength, and we're going to talk about these two equations and how we do those to get to here.